Assalamualaikum warahmatullahi wabarakatuh.
Greetings to all of us. My name is Ahmad Ghazi Nayana.
And I am Gerry Bima Putra.
And we are from
Cahaya Islamic High School.
Each person has their own unique identities. As a result, the method of expressing feelings tends to be distinct. In the past, people had to wait several months to get a reply back from their pen pals. However, in this past few years, technology has developed so much. Now, you can have a conference with anyone in any part of the world without actually having to leave your home. You can understand people talking in an entirely different language using what's called Google Translate. You can buy or even negotiate with sellers from around the world within the comfort of your own home. The way humans communicate and exchange information has diverged dramatically. As a consequence, the way we behave and interact with each other will also change significantly.
The honorable jury of the Indonesian Science Project Olympiad. As I have mentioned before, communication in general has immensely improved in such a short amount of time. However, despite all of those technological advancements such as cell phones and the internet, which lets people communicate and send information to each other disregarding their distance, there are still people who to this day still have a hard time engaging in a basic conversation, and they are people with hearing and speech disability. In daily life, it is much more difficult for them to engage in a reciprocal conversation. As a result, they are often ignored and rarely addressed in society. Some of the challenges that the hearing and speech impaired face in daily life are as follows. It is difficult for them to hear what their interlocutors are saying, which means most people that uses hearing aids still have a hard time capturing what their interlocutors are saying. And then, most people in this world go through their lives without ever learning sign language. As a result, it is impossible for the speech impaired to communicate with people in general without any sort of assistance. With this research, we had a vision to develop a device that is able to translate sign language into English as quickly and as accurate as possible. Then, we wanted to make communication between the speech impaired and normal people in general a lot easier and a lot more accessible.
To start off, some of the problems that we need to solve during this research are as follows. What method is the most effective to detect hand and finger movement? How to calibrate multiple sensors inputs so they can be interpreted? How to develop a more accurate translation? How to convert inputs that have been collected to words? A solution that we believe could contribute to patching this hole in society is the sign language translation tool with motion detection in the forms of glove based on Arduino Uno, or in the short SLIDE. It's the prototype we have developed using the MPU6050 sensor and some potentiometers to detect hand position and finger movement. It is able to translate sign language into English in a real time in a way that makes conversation for the speech impaired possible.
This research was conducted in the Laboratory of Physics of Cahaya Islamic High School.
The tools and components we need for this prototype are as follows: a pair of scissors, a glove, a female-to-male cable, a male-to-male cable, the MPU6050 sensor, a potentiometer, a glue gun, and a piece of cardboard.
And also the Arduino Uno, which is a microcontroller that would act as the brain of the device, and the breadboard, which is used to deliver electricity to multiple components. To start off, make a hole in the cardboard for the potentiometer to sit in. Then, plug in 3 female jumper cables to the potentiometer. After that, glue a pencil a few centimeters away behind the potentiometer to act as a pole for a rubber band. The rubber band will be used to pull back a flat rope attached to the tip of the finger. Repeat this process 5 times and it will look like this. To set up the MPU6050, we have to attach its feet to the main body using lead and solder. After that, attach the MPU6050 feet to the breadboard. And lastly, plug in 4 male cables to the VCC, ground, SCL, and SDA port.
The full circuit will look like this. For the code, we have to start with void setup. The code that is put in here will only be read once. Next, we create a void loop to read input from the potentiometer, then max variable according to its potentiometer. To trigger the sensor input from the MPU6050, write this code.
The table shows the data collected from the potentiometer's testing. We can see from the table, the cells that are highlighted green indicates the fingers being held up. The red cells indicate the fingers being bent down. and the yellow cells indicate the limit of finger movement. The reason each finger has different range is because they are different in length. This test allows us to determine the maximum range our fingers move using the potentiometers as reference. As seen in the table, in the MPO 6050 sensor, we use three axes, x-axis, y-axis, and z-axis. In this table, we compare the three states of lying flat, tilted, and upright. It can be seen in the table that the x-axis changes significantly, and the z-axis also changes significantly, while the y-axis does not change much. With that said, to calibrate the MPO 6050, we will only use the x-axis and z-axis inputs. Through this test, we can use the data to set conditions for the Arduino so it can tell the position our hand is currently in. From the table, we take the inputs from the potentiometers for each fingers and then note their values in each sign word. This test allows us to combine the range of the motion to set condition encoding for each word in Arduino.
Based on the data we have collected, these are conditions we have set in the Arduino to generate words.
Hello, Gerry. That's a cool device on your hand. Thanks, man. I love you too, bro.
By the end of this research, we are able to draw three conclusions. By combining the inputs and setting conditions for them, we are able to determine how many fingers are being held up and what position the subject's hands are in. The second one, Slime is able to translate hand movements to a certain extent, but it needs a manual vocabulary expansion. And the last one, although there are occasional inaccuracies, the translation of the prototype are quite dependable and can be further improved. That concludes our presentation about our project.
We hope you can take something out of it. Thank you for your attention.
And see you later.
Wassalamualaikum warahmatullahi wabarakatuh.